Today's topic is non-parametric method part 3. Let's start with the second test. One sample sign test. One sample sign test is a non-parametric method which is used as an alternative to the one sample t-test, where the null hypothesis is mu, which is equal to mu0, against a suitable alternative hypothesis. The only assumptions underlying the sign test are: population sample is continuous and symmetrical. So the only assumption is population is continuous and symmetrical. We assume that the population is continuous so that there is zero probability of getting a value equal to mu0, and we do not even need the assumption of symmetry if we change the null hypothesis to mu is equal to mu0, where mu is the population mean or median. In the sign test, we replace each sample value exceeding mu0 with a plus sign. So if the sample value is greater than mu0, then we replace by plus sign. If the value is less than mu0, we replace by minus or negative sign. Then we test the null hypothesis H0, that x, the number of plus sign, is a value of a random variable having binomial distribution with parameters n and probability theta is equal to half. I repeat again. In the sign test, we replace each sample value exceeding, that is greater than mu0, replaced by positive sign, and less than mu0 is replaced by negative sign. And then we test the null hypothesis H0, that x, the number of plus sign, is a value of random variable having binomial distribution with parameters n and probability theta is equal to half. The two-sided alternative hypothesis H1 is such that mu not equal to mu0, thus becomes theta not equal to half. And one-sided alternatives mu less than mu0 and mu greater than mu0 becomes theta less than half and theta greater than half respectively. If a sample value equals mu0, which can happen when we deal with rounded data, even though the population is continuous, we simply discard it. In order to perform a sign test, when the sample size is very small, we use the table of binomial probabilities, and when the sample size is large, we use normal approximation to the binomial distribution. So, when the sample is small, then we use table of binomial probabilities. But when the sample is large, then we use normal approximation to the binomial distribution. where mean is equal to n theta, variance is equal to n theta into 1 minus theta, standard error is equal to n theta into 1 minus theta whole root under, and the test statistic in this case is z, which is equal to x minus n theta divided by root under n theta 1 minus theta divided by. So I'll repeat again. Mean is equal to n theta, variance n theta into 1 minus theta, standard error is theta, which is equal to root under n theta bracket into 1 minus theta, and z is equal to x minus n theta divided by root under n theta into 1 minus theta, and here theta is equal to half and x is equal to number of positive signs. Let us proceed with an example. The following are the measurements of breaking strength of a certain kind of 2-inch cotton ribbon in pounds. Here is the table. So this is the given table. Use the sign test to test the null hypothesis. Mu is equal to 160 against the hypothesis mu greater than 160 at the 0.05 level of significance. Let's move on to the solution. Number 1. Null hypothesis. H0 mu is equal to 160. An alternative hypothesis H1 is mu greater than 160. It is a one-tailed test. Level of significance. Alpha is equal to 0.05. Test statistic x is equal to observed number of positive sign. Repeat each value exceeding 160 with a plus sign and each value less than 160 with a minus sign, and discarding the value which equals to 160 we get plus, plus, 0, plus, 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 minus, minus, plus, 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 minus, plus, plus, minus, plus, 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 plus. So here we give a plus sign for the values which are greater than 160 and a negative sign for the ones which are less than 160 and a 0 for the one which is equal to 160. Here n is equal to total number of plus and minus, positive sign plus negative sign, which is equal to 19, and x is equal to positive sign, which is equal to 15. It is a case of binomial distribution. From the binomial table given at the end, we find P, which is x greater than equal to 15, is equal to 0.0095, for theta equal to half and n equal to 19. For theta is equal to 0.05, P x greater than equal to 15 is equal to P x equal to 15 plus P x equal to 16 plus, it goes on till P x equal to 19, which is equal to 0.0074 plus 0.0018 plus 0.0003 plus 0.0000 plus 0.0000, which is equal to 0.0095. And hence, now the decision. Since P value is equal to 0.0095, which is less than 0.05, so null hypothesis is rejected. And we conclude that the mean breaking strength of given kind of ribbon exceeds 160. Hence, this is the solution.